In this video, we're going to talk about for loops. Now, in topic 4, we talked about for each loops. So for loops are very closely related to for each loops, but they are a bit more powerful, and there's some more things we can do with them. But given that they're more powerful, they're slightly more complex to use. So you'll remember in a for each loop, we had some sort of collection, an array or an array list. And so we're basically saying for each item in that collection. For loops are a bit different. When we declare one, we need to initialize a variable. Then we need to declare some condition that we're going to compare the variable to. And then we need to supply something that will change the variable each time it loops. So there's 3 things we need in our declaration of a for loop. A for each loop only needed 2. We needed to declare a variable of the same element type as the collection, and then we needed to provide the collection that we're going to loop through. But a for loop requires 3 things. We need to initialize our variable, provide a condition, and then some statement that's going to change the variable each time it loops. And then of course we have the body of our loop, the code that's going to run each time the loop runs. So let's have a look at an example here. So you can see I've got this method called test for loop. So you can see here is my for loop. Let me just comment this one out for a moment, because when I run this, I don't want to run that yet. So let's have a look at it. So going back to how we have to declare it, initialize variable. Well, you can see I've initialized a variable, int I equals 1. Then next you can see I need to provide a condition. Well, I've done that. I is less than 10. And then finally, I need to provide my condition to change my variable. And you can see that I've gone I++. So let's talk about this a little bit further. First of all, when I initialize my variable, you can see I've just called my variable I. That's acceptable. Anywhere else we declare a variable, we should give it a proper name. So if I declared an instance variable of type int, I would give it a name. Remember, it has to have a descriptive name and it must be lower camel case. Loops are one of the few places where you can declare a variable and just call it I or X or Y. And you'll see for loops are usually I or X. For int X equals 0, for int I equals 0. That's fine. This is one of the few places where you can use a name like this for a variable and you're not going to lose marks, and it's acceptable in Java. So for int I equals 0, I is less than 10. That's my condition, and here is my change. Now plus plus just means add 1 to I. Anywhere you see plus plus, it just means add 1 to that int. And we could only use plus plus on an int or an integer or some sort of number. So what's going to happen here? When we hit this for loop, I is going to be equal to 0. Then we're going to compare I to the condition. So what we're saying is I less than 10? Yes, it is. So because it is, we would loop and we would run this code. At the end of the loop, this is where the change comes into play. At the end of the loop, we're going to add 1 to I. So then we're going to go back up to this for loop. I will now be equal to 1. Is 1 less than 10? Yes, it is. So loop. When we finish the loop, the change happens again. So we would add 1 to I. We come back up to the top of the loop here. I is now equal to 2. Is 2 less than 10? Yes, it is. So loop. And you can see where this is going. We would add 1 to I to be equal to 3, then 4, then 5, then 6, then 7, then 8, then 9. But once I is equal to 9 and we hit this point, and we change it, and I is equal to 10, we're going to come back up to here. Is 10 less than 10? No, it is not. So we finish the loop, and then we would start running code, the following code, the code that follows the for loop. So this for loop will keep running as long as this condition is true. And every time it loops, we make this change. And we can test this. So what we should see happening is it prints out 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And let's check that. So I'll compile this. I'll create a new instance of topic 5. I will test my for loop. And we can see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I'm not doing anything useful, I'm just printing out the value of I. So let's test another one. I could do it up to 100, that's fine. Let's check that. So compile it, create a new instance of topic 5, and let's run test for loop. And there we can see it went up to 99. We can do whatever we want. We could maybe make I equal to 10. I could say, well, I is greater than 0. I minus minus. Now it's going to count backwards. So let's check that. So I'll compile, create a new object, run test for loop, and we can see now it started at 10, it counted down while I is greater than 0. And I mean, I could make, well, I is greater than minus 10 if I wanted. Let's check that. So compile, new object, test for loop. So now we can see it counted down to minus 9. So we can do whatever condition we want. What you need to do though is make sure that condition will be true at some time. What would happen if I left this, but I left this as plus plus? Well, I starts at 10, then it's going to be 11, 12, 13, 14, 15, and you can see where I'm going with this. It's never going to be, it'll keep going while it's greater than minus 10. And because I started at 10 and I'm adding to 10, it's always going to be greater than minus 10. This is what we would call an endless loop. This loop would just keep looping and looping and looping because this condition would never be false. So it would loop and it would loop and it would loop, and eventually the program would crash. It would run out of memory. So we must make sure that at some point this condition is going to be false, otherwise we would never break out of our loop. So what would we use this loop for? Where would we use it instead of a for each loop? Well, we use it when we need to know how many times we've looped. Because I've got a counter here, I can use this as a counter, and if I need to know a value of the loop that I'm up to, maybe a count of the loop that I'm up to, or maybe I need to have some sort of counter iterating that I'm going to use, then I would use a for loop. I've got an example here. Let me just show you this. In this time, I'm using a collection, an array. Remember, we know it's an array because it has the square brackets. You'll remember when I initialize an array, I've got to give it a size, which I've done, and I've initialized all of my elements in the array. So I could have used a for each loop, but I'm just using this as an example. We can get items out of an array using an index. So you can see I've gone for int I equals 0. I is less than names.length. .length returns the length of an array. So this is going to start at 0 and it's going to get me the element at index 0. Then it's going to be equal to 1. It's going to get me the element at index 1. And then it's going to be equal to 2 and it's going to get me the element at index 2. Because names.length is equal to 3, it won't loop past 2. So in this case, I'm getting the elements out of an array. Now let me just comment this. So I could have used a for each loop here. I'm just showing you how I'd use a for loop. And there's many other times or many other places that you want to use a for loop instead of a for each loop. For each loops are only really good for getting things out of collections, or maybe if you search a database and you get a result set back from a database and you want to loop through that. For each loops are good at looping through collections of some sort. But any other time you want to loop, you're not going to use a for each loop, you'd use a traditional for loop. And just a bit of history, for each loops only came out in Java 6. Prior to Java 6, we only had for loops, so you would have had to access an array using a for loop or a collection using a for loop. So in this case here, this is going to use the value of I as the index, and it's going to use that index to get the value out of the array, and we can check this here. So I'll compile, create a new instance of topic 5, and test for loop, and we can see Alex, David, and Harry.